In this session, we'll discuss the conversion of decimal to any other radix. It includes conversion of integer part and conversion of fractional part. Conversion of integer part is done by successive division method. Successive division means repeated division. And conversion of fractional part is done by successive multiplication. That means continuous multiplication. So the method is to divide the integer part by the desired base number, write the quotient and reminders, consider this new quotient as the new integer part, divide it again, write all the reminders until the quotient becomes 0, and write all these reminders in the reverse order to get the equivalent number. So for example, if you want to convert 31 base 10 decimal number to base 2, so here the base is 2, so we need to divide it by 2. So 31 divided by 2, quotient is 15, remainder is 1. Then 15 divided by 2, quotient is 7, remainder is 1. Again 7 divided by 2, quotient is 3, remainder is 1. 3 divided by 2, quotient is 1, remainder is 1. 1 divided by 2, quotient is 0, remainder is 1. Now we got all these reminders. Write all these reminders in the reverse order. Then we will get the equivalent binary number for this decimal number 31. Now we will see how to convert the fractional part. So for example, if you want to convert 0.125 decimal number to binary number and the desired base value is 2, so we need to perform the repeated multiplication by the number 2. So first multiplication 0.125 into 2, we are getting the product as 0.250. And for this product, the integer part is 0 that we need to write aside. And the next multiplication is done with 0.250 into 2. We are getting the product as 0.500 and the integer part is 0 that we are writing it aside. And the next multiplication is done with 0.500 into 2. We are getting 1.000 whose integer part is 1. And this repeated multiplication should be continued till we get the fractional part as 0, or if you have got enough digits after the binary point. Now we have written all these integer parts aside and we need to write these integer parts in the downside direction after the binary point to get the equivalent binary number. So here it is 0, 0, 1. So after the binary point 0, 0, 1. So this is the equivalent binary number for the given decimal number. So now we will see an example in which both integer and fractional parts are there. So for example, 12.625 base 10 we want to convert into binary number whose base is 2. So here the integer part is done with successive division method and the fractional part is done with successive multiplication by 2. So first integer part is 12. So we are taking 12 by 2. Quotient is 6, remainder is 0. Then 6 by 2, quotient is 3, remainder is 0. Then 3 by 2, quotient is 1, remainder is 1. 1 by 2, quotient is 0, remainder is 1. And writing all these reminders in the reverse order to get the equivalent integer part. That means 1100, 1100. Now we are going to convert the fractional part. So fractional part is 0.625 into 2. We are getting it as 1.250. The integer part is 1 that we are writing aside. Then the next multiplication is done with 0.250 into 2. We are getting the product as 0.500. The integer part is 0, writing it aside. Next multiplication 0.500 into 2. We are getting the product as 1.000. The integer part is 1, writing it aside. We can stop the multiplication here because we got the fractional part as 0. And we are writing all these integer part in the same order. That means in the downside order. What is that? 101. So after the binary point, we are writing it as 101. So this is the binary equivalent of the given decimal number. So in the same way, if you want to convert any decimal number to octal number base is 8. So here we need to do the successive division by 8 and successive multiplication by 8. So we'll see this 658.825 we need to convert into octal number system. So the integer part is 658. So 658 divided by 8. We are getting it as 82. Remainder is 2. Then 82 divided by 2. 10. Remainder 2. 10 divided by 8, 1, remainder 2, 1 divided by 8, 0, remainder 1. So we got all the reminders, writing all the reminders in the reverse order, 1, 2, 2, 2. We are getting the integer part. Then we have to go for the conversion of fractional part. So here it is 825.825. So first multiplication 0.825 into 8. The product is 6.600. The integer part is 6, writing it aside. Next multiplication is 0.600 into 8. We are getting it as 4.800. Integer part is 4, writing it aside. Then next multiplication is 0.800 into 8. The answer is 6.400. The 6 I am writing it aside. I am stopping it here because I want only 3 digits. You can go for 3 or 4 digits up to your wish. So here we need to write it in the same order. So 646 after the point, after the octal point, 646. So the total answer is 1222.646 base 8. So the next conversion is decimal to hexadecimal. Hexadecimal base is 16. So we have to go for the successive division by 16 and successive multiplication by 16. So the number is 5386.345 base 10. So the integer part is 5386, that is divided by 16. Quotient is 336 and the remainder is 10. Then 336 divided by 16, 21, remainder 0. 21 divided by 16, 1, remainder 5. 1 divided by 16, 0, remainder 1. Now we need to write all these reminders in the reverse order, and here we have the first remainder 10, but 10 is equivalent to A in hexadecimal number. So we need, in place of 10 we need to write it as A. So the answer is what? 150A. Now the fractional part is 0.345. So 0.345 into 16 will get it as 5.52. This 5 is the integer part. We are recording it aside. Then the next multiplication 0.52 into 16, 8.32. 8 we are writing aside. The next multiplication 0.32 into 16, it is 5.12. 5 we are writing aside. Then 0.12 into 16, we are getting 1.92. This number is 1, so that we are writing aside. I'm stopping here after I got 4 digits after the point. So this should be written in the same order. So the number will be 5851. So 5851 base 16. So this is the hexadecimal equivalent of the given decimal number.